Hey yo, 7th grade. We're jumping into the first lesson of chapter 9 today. The good news is some of this will definitely be review from past years. I know you did some of these powers and exponents in 6th grade. We'll have a few new things too, but hopefully you'll find this fairly simple today. What they're going to teach you today is for when you have numbers with powers like such, this big number is always called the base. Okay, so if they talk about the base today, that's what they mean. And the name for this floating number is either the exponent or another name for it is the power. Okay, so big number base, exponent, or power for the floating number. Then there are special ways to say and solve powers. Anything to the zero power. A little bit funky. I really want you to remember this today. Anything to the zero power always equals 1. So no matter what number you have, 7 to the zero power is 1, 10 to the zero power is 1, 100,000, 100 to the zero power is 1. Okay, just remember that. Any number to the zero power always equals 1. That's an easy thing to forget, okay? Otherwise, the way you say powers is like for if you have a floating number 1, you say 5 to the first power. There's a special name for something with a 2 floating. We call that squared, right? So this would be 5 squared or 7 squared or 8 squared, right? If there's a floating number 3, we could say 5 to the third power, but there's also a special name for this one. We call it 5 cubed, right? And then every one after that just uses to the whatever power. So 5 to the fourth power, 5 to the fifth power, 5 to the sixth power. The two with special names are these two, squared and cubed. Okay, and then the other special thing to remember is any number to the zero power today always equals 1. Then the first part of your assignment I think you're going to find super easy. Notice they're just going to say write these using exponents. They don't even say evaluate or solve. So these are really simple. If it doesn't say evaluate, you do not even have to solve. They just want you to write it with a power. So notice there's 1, 2, 3, 4, 5, number 4s, right? So this would be the same as 4 to the fifth power. 4 to the fifth power means 4 times 4 times 4 times 4 times 4, okay? That means the same thing as this. All you have to do is write it like that and you're done. You don't even have to solve what that equals if it just says write using the exponents. So notice this one. We have 1, 2, 3 negative 8s. So we would write that one like this. Now, whenever you have a negative number, put it in parentheses. So this would be negative 8 to the third power, which means the same thing as negative 8 times negative 8 times negative 8. Don't have to solve it because it just says write it using exponents. Okay, so those will be the easy problems today. Here's a couple more examples. Notice we don't have to solve. They just want us to write it using exponents. Kind of nice. Notice there are 4 y's there, so y times y times y times y, the same thing as that is y to the fourth. That means the same thing, okay? This one, notice I've got 3 pairs of k plus 2's. So another way to write that, instead of k plus 2 times k plus 2 times k plus 2 would be this. K plus 2 to the third power, okay? You can even have more than one thing, like more than one number or variable, and write it with powers. Let's do this one. Again, they just want us to write it using exponents, no solving necessary, okay? So this would be, so this is 9 to the third power, okay? And we have two f's, f to the second power, and then we have just one g. You don't have to put a 1 next to the g. You could. It wouldn't be technically wrong to do that. You can just put g, because remember g means g to the first power, okay? So that would be the answer to this one. Don't even have to solve it or anything because it just wants you to write it using exponents. Same thing on this next one. Notice we have 2 3's, so 3 squared, right? We have 3 a's, a to the third power. That means the same thing as 3 times 3, a times a times a. So that's writing it using exponents. Okay, then they're going to have you do some PEMDAS work today. Remember this? When you're solving equations or solving math problems, you always need to follow the order of PEMDAS. And notice the one I have highlighted today. Exponents or powers you always do second. So today you're going to do anything in parentheses first, then you're going to do anything with powers or exponents, and then multiplying and dividing and adding and subtracting, okay? So don't forget the E for PEMDAS stands for exponents. We do that second today. So let's practice that a little bit. Notice this time, this fancy word up here. Remember, evaluate, if you see that in your work today, means solve. Some of the problems will just say to write it with powers. But I would say about half your problems will say evaluate, solve. So if you see that word, we do have to actually solve this. So here's our little math expression they give us. We're going to plug these two numbers in parentheses, okay? So here I go. 6 to the second power. I put that in where the plus, and then for the y, I'm going to put in negative 2 to the third power, okay? So parentheses first. I don't see anything, that we have to solve inside parentheses. We do have them, but there's nothing, no math going on inside of them, right? So let's do exponents next. Let's do this exponent. 6 times 6, right? 6 squared is the same thing as 6 times 6. 1, 6, 2 6s, right? That equals 36. So we're going to change this one to 36 plus... Now we have negative 2 to the third power. That's the same thing as negative 2 times negative 2 times negative 2, okay? A negative times a negative, so negative 2 times negative 2 gives us a positive. So we get positive 4, but then we do positive 4 times negative 2. 4 times 2 is 8, but then whenever you have a positive times a negative, it becomes negative again. So minus 8. So here's what we've got. We have 36 plus minus 8. Remember when you have two signs fighting, the minus sign always wins. So we're going to just do 36 minus 8 to solve. We have to borrow a little bit, and there we go. There's our solution for this one. We evaluated, we solved it, okay? Let's do the second one on this page. So I'm going to put in the number for b. Notice b is negative 2, okay? And now I'm going to solve. There's no parentheses that we have to do math in, so I go to exponents. Let's do this first. Negative 2 squared is the same thing as negative 2 times negative 2. Remember today, real important, anytime you take two negatives times each other, your answer is always positive. So this ends up being 10 plus 4. Real easy then, 14. So there's our final answer. We evaluated, we solved. Notice these ones also have that fancy word for solve, evaluate, right? So let's put in our pieces again. I'm going to put a 5 in for A, a negative 2 in for B, and then here's our squared, okay? Look at, we've got two signs fighting again, right? Remember, the minus always wins. So we're going to cross that out and put a minus. So I need to do whatever's in parentheses first, then I'm going to do this power, right? So notice we do have some math going on in our parentheses this time. We have 5 minus 2, which gives us 3. So that's done. So we have 3 squared. In other words, 3 squared is the same thing as 3 times 3. So 9 is our final answer. Okay, so notice we did the parentheses first, then we took the times the power, okay? The parentheses gave us 3. To the second power is the same thing as 3 times 3, which is 9. Let's try the second one. I'm going to put in what C stands for, so 2 minus 3/4 to the third power, okay? So there's nothing in parentheses that we can do for PEMDAS, so I'm moving on to exponents. Let's do this first. 3/4 to the third power is the same thing as 3/4 times 3/4 times 3/4, okay? So 3 times 3 is 9, times 3 is 27, okay? And then 4 times 4 is 16, and 16 times 4 gives us 64, okay? Can we divide those by the same number at all? I don't think we can. Neither 27 can divide by 3, but 64 can't. So that's it. That's our answer. But we're going to put that now right here. 2 minus 27 over 64. How can we do that? Well, remember, when you're subtracting a whole number minus a fraction, stack them up like this. Right? Now we need to borrow, because we can't do nothing here minus 27 over 64, right? Now remember, when we borrow from this whole number here, we look at the bottom of our fraction, and this 2 stands for 64 over 64 and 64 over 64, two wholes, right? So we're going to borrow one of these. 64 over 64. Now we can do our subtraction. 1 minus nothing gives us 1. And then remember, when you subtract fractions, the bottom stays the same. And then on top we have 64 minus 27. So we'll do a little borrowing again. 14 minus 7 is 7. 5 minus 7 is 3. And there we go. There's 2 minus 27 over 64. It's a little more complicated, but that's all stuff you've done before. Adding and subtracting fractions, multiplying fractions for the 3/4 to the third power. So feel comfortable. You've got this. I believe you have one like this. I think it's number 7. It's like a word problem. Don't be too confused by it. Basically, it's just a simple math problem where they give you a little math problem to solve. Okay, you don't overthink it. It says a tennis ball is dropped from the top of a building. After 8 seconds, the tennis ball hits the ground. The distance in meters the ball traveled is represented by this little math expression here. So in other words, solve that math expression to help you find how far the ball dropped, okay? So 4.9 times 8 squared. So there's no parenthesis math to do, right? So we go right to exponents. We need to do 8 squared first. 8 squared is the same as 8 times 8, which you guys know is 64. So I'm going to replace 8 squared with 64. So notice our last step is we just have to do 64 times 4.9, right? That's our last step. 9 times 4 is 36. 9 times 6 is 54, 55, 56, 57. Extra 0. 4 times 4 is 16. 6 times 4 is 24, 25. So we end up with 6, 13, 10, 11, and 3 with one decimal place. And so there we go. 313.6 meters is how far that ball fell. All right, I'm going to do a few of your assignment problems with you. Here's number 2. Notice in this first section, it does not say to evaluate. We're not going to solve it all. We're just going to write these numbers with exponents. So notice there's 1, 2, 3, 4, 5 d's. So this is the same thing as d to the 5th power. D to the 5th power is the same exact thing as d times d times d times d times d. Okay. Notice number 5. Here's one of these ones. We have 3 y minus 3's. So the way we can write that with exponents is that, right? That means the same thing as y minus 3 times y minus 3 times y minus 3. So those are, that first section you're going to fly through. That's really fast. All right, but a lot of the later problems, they do want you to do this fancy word, evaluate, solve, right? So let's do that for this first one. Let's put in those numbers in parentheses. Here's what the letters stand for, okay? So 3 is going to go in parentheses to the 3rd power plus 2 for number 9, okay? Don't forget to copy this work down and do it with me, okay? So we shouldn't, there's no parentheses to do, but exponents we need to do next. So 3 to the 3rd, careful, that's not 9. That's a common error I see. That's 3 times 3 times 3. Careful. A lot of people want to take this big number times that number. Don't do that. Think of it as 3 times 3 times 3. 3 times 3 is 9, but then 9 times 3 is 27. So the 3 to the 3rd power is 27 plus 2 then, right? Which equals 29. And so there's our final answer, okay? Be careful. Don't make that common mental mistake. I see that every year. People want to take the base times the power. Don't do that. The powers mean that number times itself that many times, okay? So 3 times 3 times 3 is 27, not 9. Okay, take a look at this next one, number 10. Let's do this one next. Let's put in what b stands for. So b is negative 4 minus 1 squared. Okay, following PEMDAS, we should do the math that we have in parentheses first. So we need to do this first. Negative 4, take away 1 more. Remember, when you have two negatives like that, think of it like negative 4 plus negative 1. So what does this equal? Negative 5, right? Negative 4, take away 1 more. It's like you owe your dad $4, now you borrow another dollar, now you owe him $5, right? Now we need to do exponents second. So negative 5 to the 2nd power is the same thing as negative 5 times negative 5, right? Two negatives times each other. Remember today, really important, two negatives times each other always gives you a positive answer. Whereas if you have one negative and one positive, your answer is always negative. So two negatives times each other gives us positive 25. So here's all that we have left. What the parentheses changed to positive 25. So we just have 3 times 25 left. 25, 50, 75. 3 times 25 is 75, and there's your final answer. You have evaluated. Let's do one more quick one. I wanted to see if you remembered this. Remember what anything to the 0 power always equals? It doesn't matter what that y is. Anything to the 0 power, say it out loud. I won't be able to hear you, but anything to the 0 power equals 1 every single time. Remember that? No matter if it's 100 to the 0 power or 99 to the 0 power, they always equal 1. So that equals 1 plus 9. See how easy number 30 is once you remember that little trick? There you go. There's number 30. I just wanted to make sure you didn't forget that little trick, that anything to the 0 power we learned today always equals 1. There you go. That hopefully gets you off to a good start. Don't be afraid to contact me if you need any more help. Don't forget PEMDAS today. Always do your parentheses first, your exponents second. And be careful. Something to a power does not mean this number times that number, right? So this is not 9. Careful. 3 to the 3rd power is 3 times 3 times 3. This number times itself that many times, which is 27. So watch out. That's a common error I see. Don't think take your big number times your little one. Take your big number times itself that many times, okay? Just wanted to make sure no one made that error today. Have a good day.